I'll discuss amplifier in this lecture. Amplification is a phenomenon which we observe in our day-to-day life. When you increase the volume of your TV set, your radio or your stereo, you simply amplify the audio signal. Not only that, when you talk to someone, you talk in your normal voice, but when you are angry and you shout, what do? You increase your volume. Means each one of us have got an inbuilt amplifier. Jokes apart, let us focus on the device amplifier. Amplifier is a device which increases the amplitude of the input signal. Meaning, you just get hold of a weak signal. When I say a weak signal, I simply mean that the amplitude of the signal is small. Now, feed it into an amplifier. And magically, you will get an amplified signal like this or like this. Now, remember, the positive half cycle need not get amplified as a positive half cycle only. It can also get amplified as a negative half cycle, depending upon the configuration you are going to choose. Since transistor is a 3-terminal device, so you can have 3 configurations, that is common emitter or common base or common collector. In all these 3, you can go for a PNP transistor or an NPN transistor. Now, actually you are landing here with 6 types of amplifiers. You take care of 1 and balance 5 will be already taken care of. No need to worry at all. So let me choose the most widely used configuration for our discussion, that is the common emitter configuration. So I go for common emitter. Now, in common emitter configuration, we can either go for a PNP transistor or an NPN transistor. Let us choose NPN transistor. So now we are going to discuss a common emitter amplifier using NPN transistor. The first step is to draw the circuit diagram correctly. To start with, we will draw the symbol of a transistor, keeping in mind that the emitter has to be common in both input and output circuit. So let us draw the symbol of a transistor, rather NPN transistor. So we are having here NPN transistor. Since emitter is common in both the input part as well as the output part, so naturally we mark this terminal as an emitter. So this becomes collector and this is your base. While marking the arrow in the symbol of the transistor, be careful, because the marking of the arrow in the transistor is always done in the emitter side and from P to N. Since here we are dealing with NPN transistor, so this is the emitter side, the base is P type and the emitter is N type. So we mark the arrow like this from P to N. So that makes the symbol correct. Now, let us go to the input side. In input side, we mark a symbolic input first. Then, we have to forward bias the input circuit. Forward biasing of the input means that the P-type should be connected with the positive terminal of the battery and the N-type should be connected to the negative terminal of the battery. Since this side, emitter base side, is to be forward biased and base is positive whereas emitter is negative, so we connect the base to the positive terminal of the battery and emitter to the negative terminal of the battery. Let us call it VBE. So, the input circuit is complete. Now, mark the currents. So, the base current will be marked like this and the emitter current like this. While marking, you simply follow the terminal of the battery and it will be correct. So, nothing to worry. Another check is that the arrow mark in the symbol indicates the direction of the conventional current. So, if you are moving like this, current is entering the transistor in clockwise direction only, isn't it? So, your marking is correct. Now, go for the collector side. We have to reverse bias the collector. So, let us draw a load resistor here first, through which we will be taking the output, and now we are to reverse bias the collector. Reverse biasing simply means that if collector is N-type, then connect it to positive terminal of the battery, and if collector is P-type, connect it to the negative terminal of the battery. In this case, the collector is N-type, so we will connect it with the positive terminal of battery. While marking the reverse bias, be careful that the reverse biasing is kept slightly higher than the forward bias, due to the simple reason that much force is exerted on the charge carriers and they can enter the collector region conveniently without getting much diffused in the base region. So, the basic idea is to increase the collector current. Let us mark this as VCE. Now, here we are going to get the output. So, the first stage is complete. We have drawn the circuit diagram correctly. This is the input side. We have forward biased the input and we have reverse biased the output. Now, let us try to make the equations. Mark the collector current also accordingly. So, follow the battery terminal like this. So, this is your collector current. Now, you can see that the base current and the collector current both are coming like this, isn't it? See? So, naturally, as per Kirchhoff's law, IE is equal to IB plus IC. Let us say this is equation 1. Next is, let us say the output voltage which we are going to get is V0. Then V0 must be equal to VC minus ICRL. Let us say this is equation 2. Since current IC is flowing through the load resistor, so there will be a potential drop ICRL here. So naturally, this minus this will appear as the output, isn't it? Now, to understand it, let us draw input signal again. We don't know what output we are going to get, but don't worry about that, it will fall naturally. Now, try to think what happens when the positive half cycle is fed through the input of the amplifier. The direction of the conventional current is like this, And when the positive half cycle is fed into the amplifier, naturally you are increasing the number of holes here. The direction of the holes and the direction of the conventional current are one and the same. So naturally you are going to support the conventional current. That's called increasing the forward bias. Means during the positive half cycle, the forward bias increases. Increase in forward bias means that the circuit current increases. It means the emitter current increases. Now if emitter current increases, so accordingly collector current will also increase. Due to increase in collector current, ICRL also increases. Now since VCE is fixed, so increase in ICRL means that the output will decrease, isn't it? Now hold for a second. What does the decrease in output voltage means in this circuit? Remember, the collector is connected to the positive terminal of the battery, so decrease in output voltage simply means that it becomes less positive. I repeat, since collector is connected to the positive terminal of the battery, so the decrease in output voltage means that it becomes less positive. It means the positive half cycle gets amplified as a negative half cycle. See? Now try to think what will happen during the negative half cycle. When negative half cycle is fed into the circuit, you are actually pushing electrons in the circuit, which will neutralize certain holes and will ultimately decrease the input current. Now, it means that forward bias here is going to decrease. Decrease in forward bias means the emitter current is going to decrease. As per equation 1, the decrease in emitter current will cause a decrease in collector current. Since IC decreases, so ICRL also decreases. Now decrease in ICRL will mean that the output voltage increases. See? Now what does the increase in output voltage means in this circuit? Again, follow the same mechanism. Since the collector is connected to the positive terminal of the battery, so increase in output voltage means that it becomes more positive. It means the negative half cycle gets amplified as a positive half cycle, like this. This is how amplifier amplifies a signal, isn't it?